Hello and good evening everyone. I welcome you all once again to this wonderful platform by Unacademy. Well, my dear lovely students, I believe you all are doing good and having a great time. Well, my name is Kar Khurshid Alam and you can also call me KK Sir, and I will be taking care of your whole organic chemistry, my dear lovely students. But before we move ahead, please let me know in the chats if I am perfectly audible and visible to each one of you. Please let me know in the chats quickly. Let me know in the chats quickly if I am perfectly audible and visible to each one of you. Good evening everyone. Good evening. Okay. I believe that we are live now. And let me tell you, in today's session, my dear lovely students, we are going to discuss the very important foundation of organic chemistry. You can say the most important foundation of organic chemistry, and that is IUPAC nomenclature. That means IUPAC nomenclature of organic compounds, my dear lovely students. So keep your notebook ready, and you have to be completely focused. And you have to be with me till end of this session, my dear lovely students. So, before we start today's session, my dear lovely students, mark the attendance by smashing the like button. Come on, quick. Because mark the attendance. Come on. Mark the attendance by smashing the like button. And liking the button is very mandatory, my dear lovely students. Come on, everyone. Let me know in the chats, how is the Josh for today's session? How is the Josh for today's session, my dear lovely students? How is the Josh for today's session? Come on, are you ready? Are you ready? If you are ready, then let's begin. Let's, build what we call the very basics of this topic. Okay, now if your Josh is high, then come on, show me that in your chat box. Come on, show me that in chat box. Come on. How is the Josh? Show some fire emojis. Show some what we call green hearts as well, my dear lovely students. Come on, quick. Yes. My KKNs are there or not? Come on, show me. Show me my KKNs are there or not. Come on. Come on, my dear lovely students. Yes. Come on, mark the attendance by smashing the like button, and also share the stream with everyone there, my dear lovely students, as this is totally free. Anyone can, watch this lecture. Come on, KKNs are here. Good. Fozia Kirmani. Thank you, beta. Come on. So, without wasting much more time, let's get started. My dear lovely students. Let's get started. So, we are going to discuss IUPAC nomenclature, my dear lovely students. IUPAC nomenclature of organic compounds. IUPAC nomenclature of organic compounds. Now have a look. Try to understand things properly. Try to understand things. First of all, you should know before IUPAC nomenclature, that means before naming what we call organic compounds, you all must know, you should know that there are many functional groups. And for those functional groups, you should know what is the preference order. First of all, preference order. You should know this preference order of all or different what we call functional groups. You should know, my dear lovely students, you should know the preference order. First of all. Now tell me, is this point clear? Is this point clear to you? Let me know quickly. What is the first thing you should know? First thing you should know is preference order among, what we call different functional groups. Have a look. First of all, you should know, first of all, we will write down acid family first. Which family? Acid family first. Now the question is, what is meant by acid family? That means acid and its derivatives. Acid and its derivatives. What are acid and its derivatives? So first acid family will be there. Now let me erase this and let me show which acid family. First of all, my dear lovely students, carboxylic acid should be there. Carboxylic acid should be there. And what is the functional group of carboxylic acid? You all know this, that is COOH. First of all, COOH should be there. After that, sulfonic acid. Listen carefully. Sulfonic acid. That means it's SO3H. Functional group is SO3H. After that, the preference of first acids, but among acids, first carboxylic acid and then sulfonic acid. After that, you should remember that there are 4 derivatives of carboxylic acid. Remember, 4 derivatives of carboxylic acid are there. Number 1, anhydride is there. Number 2, ester is there. Number 3, acid chloride is there. And number 4, acid amide is there. Listen carefully, my dear lovely students. Have a look. This is known as anhydride. Don't write, just try to understand. Just try to understand. This is anhydride. This is number 1 derivative. Number 2 derivative is COO and R. That means this is ester. Number 3 derivative is what we call acid chloride. Acid chloride. And number 4 is amide. Now listen carefully. Now listen carefully. How many oxygens are there in this? There are 3 oxygens. There are 3 oxygens. Now how many oxygens are present in this acid derivative? There are 2 oxygens. How many oxygens are present in this? There is 1 oxygen and there is 1 oxygen. So there is 1 oxygen in this. Similarly, there is 1 oxygen in this. Now listen carefully. First of all, you have to write down acids. But among acids, carboxylic acid first, then sulfonic acid. After that, acid derivatives. But acid derivatives, you can write down. This is a trick. I mean, say you can remember this trick simply. Use that acid derivative first, which is having more oxygens. That means anhydride first. After that, it is ester. After that, among these, acid chloride and acid amide, remember, this is acid chloride, this is amide. Among these, write acid chloride first and then amide. So, can I write down, can I erase these things? So, can I write down first that acid derivative which is having more number of oxygens? What is that? That is anhydride. Come on, we will write down this. Let me erase this thing. Let me erase this thing. First is anhydride. That acid derivative which is having more number of, oxygens, and this is the functional group of anhydride. This is the functional group anhydride. After this, we will write down ester. Ester means it is C double bond O, O and R. Have a look. This is acid derivative. This is acid derivative. Carboxylic acid derivatives both. But this is having 3 oxygen. This is having 2 oxygens. Then that one which is having only 1 oxygen. But there are 2, acid derivatives having only 1 oxygen. One is acid chloride. Another is amide. So write down chloride first and then amide. So let me write down over here acid chloride first. Acid chloride first. And then amide. And then amide. That means CONH2. So these are the functional groups. You have to write down these functional groups first. So first, carboxylic acid. Now you can remember these things. Now you can repeat these things with me. Come on. First, carboxylic acid, then sulfonic acid, then 4 acid derivatives or 4 derivatives of carboxylic acid. But among these, write down that one first, which is having more oxygens. Then that means anhydride having 3 oxygens, then ester having 2 oxygens. But these 2 are having 1 oxygen. But among acid chloride and amide, write acid chloride first, then amide. Is this point clear? Is this point clear? Everyone, let me know in the chats quickly. 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 Is this clear? Come on, everyone. Let me know in the chats quickly. Okay, that's great. That is great. That is great. That is great. That is great. Now, after this acid family, this was acid family. Now you have to write down those compounds which are having nitrogen, but those nitrogen containing functional groups which have multiple bonds. There are 3 nitrogen containing compounds or 3 nitrogen containing functional groups. One is cyanide, another is isocyanide, another is amine, but amines do not form double bond, amines form single bond. So we have to write down that nitrogen containing functional group which is having multiple bond. That means which is having, say triple bond, like cyanide and isocyanide. So after this, let me write down cyanide. Let me write down cyanide. That means Cn first. Cn is actually C triple bond N. And then isocyanide. That means N triple bond C. You can show it in this fashion. Now, listen carefully. Listen carefully. First, acids, carboxylic acid and then sulfonic acid. Then 4 acid derivatives. In this order, 3 oxygen, 2 oxygen and 1 oxygen. But both are having 1 oxygen. Write chloride first, then amide. But after that, you have to write down nitrogen containing functional groups. So you have to write down those nitrogen containing functional groups which contains multiple bond. That means more than 1 bond. So write down cyanide and isocyanide. Cyanide and isocyanide. Cyanide starts with C. Isocyanide starts with I. You can write down these in alphabetical order. That means which comes first in alphabetical order is written first and then isocyanide. Is this point clear to you? Is this point clear to you? Now after this, write down oxygen containing functional groups. But those oxygen containing functional groups which are not either acids nor acid derivatives. Now, first acid family, then we can simply say this as nitrogen family, but only that nitrogen family which contains multiple bond. Now, oxygen family which contains multiple bond. And there are 2, functional groups which contain multiple bond with oxygen. So one is aldehyde, another is ketone. Write down aldehyde first, alphabetical order. Aldehyde first, then you can write down ketone. Aldehyde first and then ketone. So first acid family, then nitrogen family containing multiple bond, then oxygen family containing multiple bond, but apart from these oxygens. Now, is this point clear? Now tell me quickly. Let me know in the chats quickly. Is this point clear? Come on, my dear lovely students, quick. Come on, beta. My future doctors, come on, quick. Be very much responsive, you know. I like response. Come on, very good. Very, very, very good. Very good. Very good, beta. Very good, very good, very good. Is this clear? Okay. After this, write down oxygen family, but that oxygen family which is having basically or which forms single bond. Those functional groups which contains oxygen, but these you have to write down. I mean to say those functional groups which are having oxygen but form single bond, like alcohol, like phenol. I hope this point is clear. So write down. We will write down first alcohol. That's OH. This is having O but single bond. This was having O but multiple bond. Now after that, this is the trick to remember this. Now then phenol. Phenols are also having O. But the only difference is that in case of alcohol, OH is attached to sp3 hybridized carbon. But in case of phenol, OH is directly attached to aromatic ring. I hope this point is clear. Then after that, both are having OH functional. After that, thiol or thioalcohol. That means having S, having sulfur. Now tell me, is this understood? Can you remember this now? Can you remember this now? Can you remember this now? Tell me quickly. Tell me beta quickly. Can you remember this now? It's a very simple trick. First, acid family. Among acid family, first carboxylic acid, then sulfonic acid, then acid derivatives. But among acid derivatives, that acid derivative first which is having more number of oxygen, that means anhydride, then ester, then acid chloride and amide. Among these acid chloride and amide, write down acid chloride first, then amide. After that, nitrogen family, but that nitrogen family which contains more than, I mean to say, one what we call bond, that means which is having what we call multiple bonds, and among those there are two, cyanides and isocyanides. Write down that which comes first in alphabetical order. So cyanide first, after that isocyanide. Then once again oxygen family. But these oxygen family should not be that functional group which is either acid or acid derivative. That means that will be obviously aldehyde and ketone, because this oxygen family contains multiple bond. That means that oxygen family which is having multiple bond, then that oxygen family which is having single bond. After that oxygen, write down sulfur having single bond, that means thioalcohol. Is this point clear? And then write down amine. Then after this, write down amine. Write down amine. Once again, nitrogen. But remember, this is nitrogen containing functional group, but it's not having multiple bond. This is nitrogen containing multiple bond. This is not nitrogen having multiple bond. And finally, you have to write down alkenes and alkynes. Finally, alkenes and alkynes. And you know, alkene is having carbon-carbon double bond. Alkynes have carbon-carbon triple bond with general formula CnH2n and with general formula CnH2n minus 2. Now tell me, is this clear? Now, is this beta clear? Everyone, come on. Let me know in the chats quickly. Let me know in the chats quickly. Now, these are few functional groups and you have to remember these functional groups. And now, my dear lovely student, if our organic compound contains more than one functional group, listen carefully. If our organic compound contains more than one functional group, suppose our organic compound contains carboxylic acid as well as alcohol, as well as, say, for example, thioalcohol, then only one functional group will act always as main functional group. That means the principal functional group. And that principal functional group will be only that functional group which comes first in this order. Say, for example, carboxylic acid is there, alcoholic functional group is there. Say, for example, thioalcoholic functional group is also there. So, carboxylic acid comes first in, this order. So, this becomes principal functional group or main functional group. And rest of the functional groups will act as secondary functional groups. That means as substituents. So, please note down this. That means if organic compound is having more than one functional group, then only one functional group will act as a principal functional group, and that will be that functional group which comes first in what we call this preference order, and other functional groups will act at that time as substituents. They will act as substituents. Now tell me, is this point clear? Now tell me, is this point clear? Everyone means everyone. Come on, tell me. Everyone means everyone. Come on, my dear lovely students. Come on, tell me, dear students. Come on, beta. So, among these, anyone can act as a principal functional group. Say, for example, if acid chloride is there and cyanide is there, then acid chloride will act as a principal functional group and it will act as a, substituent. Similarly, if, say, for example, thioalcohol is there and amine is there, thioalcohol comes first in order, so it will become a principal functional group and it will act as a substituent at that time. Is this point clear? But there are few functional groups, my dear lovely students. There are few functional groups. There are few functional groups. So I will write down functional groups like, say, for example, say halogens. Halogen, halides, functional group X. Similarly, functional group NO2, nitro. Functional group NO means nitroso. So please try to understand. Similarly, functional group OR means ether. Functional group, say, for example, like this. This is known as epoxy cyclic ether. So these functional groups always act as substituents. They can never act as principal functional groups. So let me write down functional groups like these: always act as substituents. That means these are the functional groups, but they will always act as substituents. They will never act as principal functional group. Now, beta, let me know in the chats, is this point clear to you? Come on, everyone. Come on, everyone. Let me know in the chats, is this point clear to you? Everyone. Everyone means everyone. Come on, beta. Okay. So you have to remember that there are functional groups like halogen, nitro, nitroso. Say this is what we call ether. They all will be acting as substituents. So this will be named as halo. This is nitro. At that time, nitroso. This will be named as alkoxy. And this will be named as epoxy. Let me write down the name over here. So this is halo. Say for example, fluorine is there. If fluorine is there, it will be fluoro. Chlorine is there, it will be chloro. Bromine is there, it will be bromo. Iodine is there, it will be iodo. Similarly, if NO2 is there, it will be named as nitro at that time. NO will be there, it will be named as nitroso at that time. If OR is there, this is the ether functional group, its name will be alk. Alk is this one, and oxygen, that means oxy. Alkoxy. Now after that, here, this is known as epoxy. This is a cyclic ether, but it will be named as epoxy. So I hope this point is clear. Now, dear lovely students, if I write down over here a compound, say for example, compound number 1, let me write down like this. Let me write down a compound like this. Now tell me, you have to tell me how many functional groups are present in this compound. You have to tell me how many functional groups are present in this compound. How many functional groups are present in this compound? Come on, let me know in the chats quickly. How many functional groups are present in this compound? Come on, let me tell you that alkenes and alkynes are also functional groups. Have a look. Alkenes and alkynes are also functional groups. Now tell me how many functional groups are present in this compound. You have to tell me how many functional groups are present in this compound. Come on, tell me, quick. Everyone has to answer. Everyone means everyone. Come on. Very good. God bless you. Everyone is giving me right answer. That's great. That's like, say future doctors. Great. That's like my KKNs. Come on. Very good. Very good. Very good. Great. So there are, my dear lovely students, listen carefully. This is what we call functional group. This is functional group. This is functional group. This is carboxylic acid. This is alcohol. This is ketone. This is alkene. This is amine. So how many functional groups are there? There are 5 functional groups. Listen carefully. In total, there are 5 functional groups. But you have to remember that if more than one functional group is present in an organic compound, only one will be always principal functional group, main functional group. Others will be secondary functional group or substituents. Now have a look. There are 5, functional groups. But according to preference order, carboxylic acid comes first. When carboxylic acid comes first in preference order, can I say this is what we call principal functional group? And principal functional group is always 1. Principal functional group is always 1. It can never be, 2. Only one type of principal functional group should be present. So this is principal functional group. These can never be principal functional groups. Are you getting me? Yes, if more than one COH groups are there, they can act as principal functional group, but type will be only 1. Only one principal functional group will be there. Okay. Now tell me, how many substituents are there? I mean to say, how many secondary functional groups are there? How many secondary functional groups are there? Come on, tell me. How many secondary functional groups are there? Come on, everyone. Everyone, answer me quickly. Answer me quickly. How many secondary functional groups are there? Yes, that is great. That is great. That is great. You have to simply crack your NEET 2027 with flying colors. Yes, great. Great. Great, great. So there will be obviously 4 what we call substituents. Now, this was example number first. Now, my dear lovely students, if I write like this, if I write down like this, have a look, it's like this, then it's having what we call like this, then say for example, it's having like this, now it's having like this. Tell me, or let me erase this and let me write down CL over here. Tell me, how many functional groups are there? Come on, everyone. How many functional groups are there? Come on, everyone. Everyone means everyone. Come on, quick. Write down the answer in the chats quickly. How many functional groups are there? How many functional groups are there? Come on, very good. Very good. How many functional groups are there? Have a look. This is one functional group. This is ether. O and alkyl part is there. Here alkyl part. O bonded to carbon. O bonded to carbon. So this is ether. So this is one functional group. This is nitro, another functional group. This is chloro, means another functional group. This is nitroso, another functional group. So how many functional groups are there? Answer. Write down, write down, write down. How many functional groups are there? 1, 2, 3, 4. There are 4 functional groups. Now tell me, my dear lovely students, how many principal functional groups are there? But let me once again tell you, principal functional group will be only that functional group which comes first in that preference order. Now tell me, is there any functional group among these? Have a look, have a look. Is there any ether in this? Answer is no. Is there any what we call nitro, nitroso or halogen in this? Answer is no. So there is no functional group in this as per this compound is concerned. So we will simply say there is no principal functional group. That means functional groups are 4 in number, but there is no principal functional group. That clearly indicates that these functional groups are those functional groups which always act as substituents or what we call secondary functional groups. My dear lovely students, how many secondary functional groups are there, or how many what we call substituents will be there? Come on, tell me. Come on, tell me. Now tell me how to name this compound. Don't go there. Don't go there. Don't write down the name directly. You have to remember, for naming an organic compound, there are 3 parts. I will tell you that after this. But before that, let me know in the chats, is this point clear? Let me know in the chats, is this point clear? Go step by step, because haste always makes waste. So don't haste at all. Now tell me, everything clear? Is everything clear, beta? Is everything clear? Now, let me write down another example. Let me write down another example over here. Example number 3. Example number 3. Example number 3 is like this. Example 3rd is this one. Look towards this structure and tell me how many functional groups are there. How many functional groups are there? How many functional groups are there? Come on, come on, come on, come on, everyone. Come on, tell me, quick. Be very much quick. How many functional groups are there? Mani Attam Ati Pamula. But it will be up to 5:40. 5:45. Class will be up to 5:45. That means more than, I mean, say, you can simply say approximately 40 minutes more. Now tell me. Come on, come on, come on, come on, tell me. How many functional groups are there? 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 How many functional Someone is writing 6. Few 5. Why is so confusion? Why 5 and 6? Why is there confusion between 5 and 6? Why is confusion there, my future doctors? Come on. Tell me, is this the functional group? Yes or no? Is this the functional group? Come on, tell me. Yes or no? Come on, respond quickly. Is this the functional group? Yes. Is this the functional group? Answer is yes. Is this the functional group? Is this the functional group? Answer is yes. It's not NH2 and CO. It is CONH2. Now, is this the functional group? Yes. So how many functional groups are there? How many functional groups are there? 1, 2, 3, 4. Sir, but C double bond C is also the functional group? Yes. It's also the functional group. So how many functional groups are there? There are 5 functional groups. There are 5 functional groups. So there are functional groups are 5 in number. Functional groups are 5 in number, but principal functional groups will be this COH, only one. And what about, I mean to say, what about substituents, or what about secondary functional groups? Substituents or secondary functional groups will be simply 4 in number. I hope this point is clear. I hope this point is clear, beta. I hope this point is clear. Now tell me, can you easily now find out functional group, principal functional group, and substituents? Can you easily find out these things? Can you easily find out these things? Can you now easily find out these things? Come on, tell me quickly. Come on, tell me quickly. Yes or no? Yes or no? Everyone has to respond. Yes or no? Afifa, yes, thank you. Jannat, crystal clear. Siddharth, yes sir, for sure. Okay, great. Dr. NEET. Okay, yes. Yes. Great means great. Okay, now, next thing is how to name an organic compound. How to name an organic compound. How to name an organic compound. Listen carefully. Naming of organic compound can be done in 3 different steps. Naming of organic compound is always done in 3 different steps. Step number one is always identification of parent chain, means main chain. So it's not that examiner has given you an organic compound and you try to name that compound. No, that's the wrong way. You have to first of all identify the parent chain. Then in second step, my dear lovely students, in second step, you have to number that parent chain. That means second step is numbering of parent chain. Numbering of parent chain. First, you have to identify the parent chain, because that is the identification of parent chain, first condition. Second condition is that you have to number that parent chain, and after that is the third one. That means this comes at the end. That means naming of an organic compound. Now, it's not that you will directly name the organic compound. No, that is the wrong way. First, you have to identify the parent chain first. Identify the parent chain first. Is this point clear? Identify the parent chain first. Then you have to number that parent chain. Once identification is done, now you have to number the parent chain now. After that, you have to name after that. Now, let's discuss step 1. Let's discuss step 1. Let's discuss step 1, my dear lovely students. That is identification of parent chain. That means we have to identify parent chain first. We have to identify parent chain first. So how to identify a parent chain? Have a look. How to identify a parent chain? Now, have a look. How to identify a parent chain? Have a look. But before going into this discussion, now let me know first of all, is everything clear till now? Is everything clear till now? Please let me know in the chats quickly. Is everything clear till now? Let me know in the chats quickly. Let me know in the chats quickly, my dear lovely students. Let me know in the chats quickly, beta. Okay, that's good. That's great. Come on, have a look. How to identify a parent chain? Simple. You have to select that chain as parent chain which contains maximum number of multiple bonds, which contains maximum number of functional groups, which contains maximum number of carbon atoms, which contains maximum number of substituents. Now the question is how to select this thing. Have a look. For that you have to follow this order. You have to follow this order, beta. First of all, that parent chain must contain principal functional group. First of all, parent chain must contain principal functional group. Is this point clear to you? Parent chain must contain principal functional group. Parent chain must contain, beta, principal functional group. Is this point clear? After that, you have to give preference to multiple bond. You have to give preference to multiple bond. Let me write down MB as multiple bond. What is meant by multiple bond? Multiple bond means two atoms having more than one bond. That means either double bond or triple bond. So first of all, first preference goes to principal functional group, then multiple bond. After that, number of carbon atoms, or maximum number of carbon atoms, you can say. Is this point clear to you? And then number of substituents. So you have to select parent chain in this fashion. So try to remember these things. First of all, you have to check principal functional group. After that, you have to check multiple bonds. That means double bond and triple bond. Maximum principal functional group, maximum multiple bonds, maximum number of carbon atoms, maximum number of substituents, or maximum number of side chains, you can say. Now, you have to go with this, preference. Now, for example, there are few compounds. Now, first of all, there is a compound. You don't have to write down the name first. You have to identify parent chain only. You have to identify parent chain. Sir, how to identify parent chain? First of all, what you have to, look. You have to look towards this compound and you have to find out principal functional group. Now tell me, how many will tell me that is there any principal functional group or not? Come on, tell me. Is there any principal functional group present or not? Is there any principal functional group present or not? Tawheed. Don't say like this, beta, that when substituent is present at lowest position, we name the compound from that position. I'm not giving you any, name. I am only trying to discuss how to identify parent chain. That's it. Delete every, thing from your mind. Delete everything from your mind. Whatever you, knows, delete everything. Whatever you knows, delete everything related to organic chemistry, related to, nomenclature. Whatever I am saying to you, try to remember that. That's it. That is it. Okay. Now, is there any functional group? Tell me answer, yes or no. Is there any principal functional group? You just tell me that only. Yes or no. Come on. Siddharth, already deleted, sir, as you said. God bless you, Siddharth. God bless you. Now, there is no principal functional group. So can I write like this? Principal functional group is not present. As principal functional group is not present, that means there is no principal functional group. But let me tell you, it's not that principal functional group is halogen. Let me erase this. Oh, let me erase this. Let me erase this, beta. It's not that principal functional group is halogen. No, I am saying principal functional group is absent. Principal functional group is absent. Now, dear students, if principal functional group is absent, after that, we have to go towards multiple bond. Now, look towards this structure and tell me, is there any double bond or any triple bond? Tell me, is there any double bond or any triple bond? Come on, everyone. Everyone means everyone. Is there any double bond or any triple bond? Come on, tell me. Come on, everyone. Come on, everyone. Waiting for your reply. No. If there is no double bond or triple bond, so let me write down second point. Multiple bond is absent. We have to go preference wise. First principal functional group, then multiple bond, but these will not basically help in identification of parent chain of this compound. So after that, what is, third one, that is number of carbon atoms. You have to check number of carbon atoms. How to check number of carbon atoms? You have to count number of carbon atoms from one end to another end, or from one terminal to another terminal. Let me tell you first of all, what is the end? Which carbon is basically the end? One end is this one. One end is this one. Another end can be this one. Another end can be this one. Have a look. End can be like this, from terminal to this terminal. From this end to this end. It can be from this end to this end, or it can be from this end to this end. Is this point clear? So how many end-to-end possibilities are there? Have a look. This is one possibility, this is another possibility, and this is another possibility. How many possibilities are there? Come on, tell me. How many possibilities are there? Come on, tell me. There are three possibilities. End-to-end. You have to check end-to-end. This is end, terminal to terminal. From this terminal to this terminal. This is one possibility. Another possibility is this one. Another possibility is this one or this one. So how many possibilities are there? Three. Now tell me, if this is the first possibility, how many carbons? You have to check number of carbons. How many carbons are in this possibility? Come on, tell me. 1, 2, 3, 4. 4 carbons are there. How many carbons are present in this possibility? 1, 2, 3, 4, 5, 6. How many carbons are present in this possibility? 1, 2, 3, 4, 5. That means there are 3 possibilities of having a parent chain. One having 4 carbons, another having 5 carbons, another having 6 carbons. Now tell me, which is having more number of carbon atoms, which is having maximum number of carbon atoms? That possibility which is having maximum number of carbon atoms will be our parent chain. Is this point clear to you? Is this point clear to you, beta? So there are 3 possibilities, my dear lovely students. One 4, another 5, another 6. But which one is having maximum number of atoms? Maximum number of carbon atoms. Come on. It is 6 1. So let me show then the parent chain. So can I simply say this is our parent chain? This is simply our parent chain. This is our parent chain. So we will simply say this is the parent chain. Now tell me, can I say this is not the part of parent chain? That carbon chain or that carbon which is not part of parent chain is simply known as side chain. Is simply known as side chain, or we can simply call it as substituent. We can simply call it as substituent. Is this point clear? Everyone. Let me know in the chats quick. Is this point clear? Is this point clear, beta? Come on, everyone. Is this point clear? That's great. That's great. That's great. That's great. Now, another thing is this one. First of all, what will we check? What will we check? So, this was on the basis of maximum number of carbon atoms. Maximum number of carbon atoms. We have decided parent chain on the basis of maximum number of carbon atoms. Is this point clear to you? Now here, first of all, what will we check? We will check principal functional group. And principal functional group is absent. Principal functional group is absent. After that, what we have to check? Multiple bond. Can I say multiple bond is once again absent? Multiple bond once again is absent. Now, my dear lovely students, you have to check now end to end, terminal to terminal, because we have to find out maximum number of carbon atoms now. Have a look. This is one end. This is another end. This is another end. This is another end. Is this point clear to you? End means these CH3 groups. These are the ends like this. So this is end, this is end, this is end, this is end. Now, one possibility is like this. Have a look. One possibility is like this or like this. This is one of the possibilities. Another possibility is like this. Another possibility is like this, or this one, or this one. So have a look, have a look. This is one possibility, or this one. This is another, or this one. This is another possibility, or you can say this is another possibility. Three possibilities are there. Now this is fourth one. This is fourth one. Now there are four possibilities. There are four possibilities. Possibility number one is having 4 carbons. Let me write down. This is having 4 carbons. Possibility number 2, 1, 2, 3, 4, 5. So this is having 5 carbons. Is this point clear to you? If you want, you can write down like this. This possibility is like this. This and this. This and this is having 4 carbons. What about this straight chain? Straight chain is having 5 carbons. What about this one? What about this one? Have a look. What about this one? This and this. How many carbons? 1, 2, 3, 4, 5, 6. 6 carbons are there. Okay, what about this? 1, 2, 3, 4, 5, 6, 7. That means this possibility. There is another possibility like this. There is another possibility like this. So this is having 7 carbons. Now tell me, among these 4 possibilities, which one will be preferred? Come on, tell me. Which one will be preferred? Come on everyone. Come on everyone. Which one will be preferred? Which one will be preferred? 4, 5, 6 or 7? 4, 5, 6 or 7? Come on everyone. 4, 5, 6 or 7? Everyone means everyone. 4, 5, 6 or 7? Now, for that you have to check how many possibilities are there. 4 possibilities are there. So maximum number of carbon atoms are present in this one. So we will, use this thing. So let me erase these things and let me write down answer over here. So once again, on the basis of maximum number of carbon atoms, is 7 carbons, isn't it? Here maximum number of carbon atoms was 3 and 3, 6. So here it was 6 carbon. That's parent chain. So parent chain over here will be like this. This will be our parent chain. This will be our parent chain. Is this point clear? Is this point clear till now? Is everything clear till now? Tell me, is everything clear till now? Everyone. Come on. Great. Come on. After that, there is one more compound. Come on. Can I say principal functional group is absent? Second. What we have to check? Come on, tell me. Second one. What we have to check second? Second is, sir, multiple bonds. Multiple bond is also absent. After that, what we have to check? Don't number the chain. Don't name the compound. Just try to identify what we call, parent chain, main chain. Now, what are the ends? This is one of the ends. This is another end. This can be another end. Among these two, anyone can be end. Now, this can be another terminal or end. Now, have a look. If we look towards this end, if we go in this direction, 1, 2, 3, 4, 5, 6. So 6 carbons are there. If we go like this, 1, 2, 3, 4 and 5, like this, it is 5. 5 carbons, like this. Is this point clear to you? So either this or this is 6 carbon, either this or this 5 carbon. Similarly, 1, 2, 3, 4, 5, either this or this 5 carbon. Let me write down like this. This also 5 carbon. Now, is this point clear to you? Now, 1, 2, 3, 4, 5, 6. This is also having 6 carbons. Is this point clear to you? Now tell me, look towards these and tell me which can be, our parent chain. Now tell me, can I say either this one or this one? Either this one or this one. Either this one or this one can be our parent chain. Yes or no? Come on, tell me. Come on, tell me. Can I say either this one is the parent chain or this one is the parent chain? This can never be a parent chain. This can never be a parent chain because these are having lesser number of carbon atoms. Come on, tell me. Is this point clear to you? Is this point clear to you, beta? Is this point clear to you? Now, when number of carbon atoms are same, in more than one parent chain, that means when number of carbon atoms will not decide which chain can act as a parent chain, at that time you have to go towards number of substituents. Come on, have a look. So either this is the parent chain or this is the parent chain. That means maximum number of carbon atoms are having 6 carbons, but it is possible in 2 ways. 6 carbons in 2 ways. What was that? Number one was in this fashion, there was 6 carbons, or number second was this one, there was 6 carbons. Now, how to distinguish these with the help of number of substituents? Now have a look. When we talk about this one, first of all, let me erase these things. When we talk about straight chain, have a look. If this is the parent chain, have a look. If this is the parent chain, that means this will be the substituent, this whole will be the substituent. Now tell me, if this is the parent chain, how many substituents are possible at that time? 2. Now tell me, is this point clear? If this is the parent chain, there are 2 substituents. Is this point clear? Is this point clear? Come on, tell me. Everyone respond quickly. Come on, my dear doctors, future doctors, come on. Yes, very good, very good. So if this is the parent chain, there are 2 substituents. That means with respect to this, number of substituents are 2. So I will write down 2 substituents are there. But what about this one? Let me erase this once again. Have a look. Try to understand things. If this is the parent chain, now if this is the parent chain, this one, 1, 2, 3, 4, 5, 6 carbons are there. Now substituent is 1, this is another, this is another, this is another. So how many substituents are there? There are 4 substituents. Now tell me, number of carbon atoms cannot decide what we call which one is parent chain. Then you have to go to number of substituents. So can I simply say this will be the parent chain, this will not be the parent chain? Now this is the parent chain now, beta. Is this point clear? Now tell me, is everything clear to you? Is everything clear to you? Come on everyone. And one more thing I want to tell you, beta, if you have not enrolled Phoenix 3.0 yet, enroll Phoenix 3.0 as soon as possible. Link is in the description. Click that link and enroll right now, because here we are going to teach you everything in detail, and that too from basics to advanced level. So don't miss this opportunity. Now have a look. After this, if we talk about this one, can I say principal functional group is absent? Principal functional group is absent once again. After this, multiple bond is once again absent. After this, multiple bond is once again absent. After that, maximum number of carbon atoms we have to find out. Now come on, tell me. This is one end, this is another end. So 1, 2, 3, this is one of the possibilities. So this is one of the possibilities, 3 carbons. 1, 2, 3, 4, 5, this is another end. So it can be what we call like this, 5 carbons. Another possibility is 1, 2, 3, 4, 5. That means like this. Have a look. Like this. 5 carbons are already there. After that, another possibility is 1, 2, 3, 4, 5, 6 straight. 1, 2, 3, 4, 5, 6. That means straight is 6. Or this one is also 6. This one is also 6. You have to check all the possibilities. Now, what about this one? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That means this is another possibility. Have a look. This is another possibility. This is having 6 carbons once again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Straight line. 1, 2, 3, 4, 5, 6. This one. So 6 carbon, 6 carbon, 6 carbon. So this and this is one and the same. These are same because this is having, say one substituent and another substituent. So let me erase these things now. Let me erase these things now. So this can never be a parent chain. This can never be a parent chain. This can never be a parent chain. Parent chain are 3 in number. So 3 ways. Now have a look. If this is the parent chain, if this is the parent chain, if this is the parent chain, this is the substituent, this is the substituent. Now have a look. If this is the parent chain, 6 carbons, number of substituents at that time is 2. 2 substituents are there. If this is the parent chain, 2 substituents are there. Now let me erase this thing. Let me erase this thing. Now, if this is the parent chain, have a look. If this is the parent chain, if this is the parent chain, once again, one substituent, another substituent. So, if this is the parent chain, 6 carbons with 2 substituents. Done? Now. Let me erase this once again. Let's check another possibility. What is another possibility? Another possibility is this one. 1, 2, 3, 4, 5, 6. That means this is having 6 carbons. But how many substituents are there? Have a look. Only one. Only one substituent is there. Tell me, can I say this is not possible? Either this is possible or this is possible. Is this point clear to you? Is this point clear to you? Now, can I say simply straight chain here is the parent chain. So this is our parent chain. This is our parent chain, my dear lovely students. Obviously, this will be the side chain, this will be the side chain. So 2 substituents or 2 side chains are there. Now let me know in the chats. Now let me know in the chats. Is this point clear to you? Is this point clear to you, beta? Is this point clear to you? Come on, let me know quickly. Let me know quickly. Come on, dear students. Is this clear? Now, if this is clear, tell me what about this? Tell me what about this? Come on, quick. What about this? What about this? First of all, we have to check principal functional group. Principal functional group is absent. Principal functional group is absent. Now, second one, you have to check multiple bond. Is multiple bond present? Multiple bond is present. Multiple bond is present. If multiple bond is present, now you have to check. Multiple bond can be present from, you have to check terminal to terminal. Say for example, this is one terminal to terminal. Multiple bond is present. One multiple bond is present in this. So 1, 2, 3, 4 carbons are there. So can I say, if this is the parent chain, if this is the parent chain, multiple bond is present. Multiple bond is 1 in number. Number of carbons are 4 in number. Yes or no? Similarly, this can never be a parent chain. Why? Why this can never be a parent chain? Because parent chain must contain maximum number of multiple bonds. But this is not having any carbon-carbon double bond. This is not having carbon-carbon double bond. Have a look. This is carbon-carbon double bond. So there are 2 possibilities. One is this one. Another is this one. Another is this one. So if we say this is the parent chain, then multiple bond is once again 1. Multiple bond is once again 1. Okay, now how many carbons? 1, 2, 3, 4, 5 carbons. So number of carbons are 5. Number of carbons are 5. Now tell me, if I write like this, can I say multiple bond is absent? Multiple bond is absent in this case. Now tell me, multiple bond is present in these cases, multiple bond is absent in this case. Can I say it can never be a functional group? It can never be a principal chain, parent chain. It can never be a parent chain. But what about these 2? Multiple bond is 1 in number, 1 in number. Both are having multiple bond 1 in number. That means multiple bond will never tell which one is the parent chain. It will not say whether this is the parent chain or this is the parent chain, because both are having 1 multiple bond. After that, we have to go to number of carbon atoms. Number of carbon atoms are 4, number of carbon atoms are 5. Which one is having maximum number of carbon atoms? Straight chain. So straight chain will be our parent chain. Straight chain will be our parent chain. So this is the parent chain. Obviously, this will become the substituent. or this will become what we call a side chain. So this is the substituent or this is the side chain. Tell me beta, is this clear? Tell me beta, is this clear? Everyone beta? Everyone beta, quick. Come on beta, quick. Beta, Ria beta, you have to go according to this. Ria beta, you have to go according to this. If principal functional group is absent or principal functional group will not decide the parent chain, you have to go to multiple bond. Multiple bond is present, or if multiple bond is absent, then you have to go to this. But if multiple bond is present, then you have to check whether multiple bond, can identify the parent chain or not. Have a look. In our case, multiple bond was 1 and 1 in both the cases. Multiple bond 1, multiple bond 1. That means multiple bond is not different. Multiple bond cannot tell us whether this is the parent chain or this is the parent chain. So when multiple bond will not answer, then we have to go to number of carbon atoms. Have a look. We have to check maximum number of carbon atoms now. Have a look. This is having number of carbon atoms 4, number of carbon atoms 5. Sir, this was having number of carbon atom 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6. So this was having more number of carbon. No. First multiple bond and then number of carbon atoms, as multiple bond is absent. So these are having multiple bond is present. So whether either this will be the parent chain or this will be the parent chain. But this is having 4 number of carbons, this is having 5 carbons. So which one will be, preferable? This one will be preferred, this one will not be preferred. So this will be our parent chain. That's why parent chain is straight parent chain. Ria, is this point clear to you beta? Ria beta, is this clear to you? In previous slide, which one? Which one beta? This one. This was having 6 carbons and 2 substituents. Either this is the parent chain or this is the parent chain. Have a look. This is one and the same. This is the parent chain having 2 substituents. This is the parent chain having 2 substituents. Either this or this, because both maximum number of carbons are equal, substituents are equal. So I have, said that both these are correct. Both these are correct. It's up to you now. You can take straight chain or you can take this one. You can take this one or you can take straight chain. But this can never be the parent chain. This can never be the parent chain because substituent at that time is only 1. Ria beta, is this clear? Yes, at the rate of JEE Advanced lost. Yes, if you watch my lectures from start till end, you can crack JEE mains easily. You can crack JEE mains easily beta. Okay. After that, look towards this one. Beta. First of all, tell me. First of all, you have to check principal functional group. Is there any principal functional group? Is principal functional group present? Yes. Which one is the principal functional group? This one is the principal functional group. And remember, our parent chain must contain principal functional group. Now look towards this. This does not have any carbon. Principal functional group does not have any carbon. So whenever principal functional group does not have any carbon, then the principal functional group attached to the carbon, this carbon should be included within the parent chain. This carbon should be included in the parent chain. Now tell me, if this carbon should be included in the parent chain, how to include this carbon in the parent chain? Either this side or this side. Either this side or this side. Have a look. When you look towards this chain, 1, 2, 3, 4. 4 carbons are there. Yes or no? When you look towards this, 4 carbons are there. So either this is the parent chain or this is the parent chain. This can never be the parent chain. Why? Why this can never be the parent chain? Because that carbon has not been included to which principal functional group is attached. Is this point clear? Is this point clear, beta? So the principal functional group attached to the carbon should be included if principal functional group does not have any carbon. So it should be included within the parent chain. So both are having 4 carbons. Either this is the parent chain or this is the parent chain. But when we talk about this parent chain, at that time, this is the substituent. 1 is the substituent. Only 1 substituent is there. So 1 substituent is there. If this is the parent chain, at that time 1 substituent will be there. What does that mean? That means this and this both are correct. So you can take anyone as parent chain. Say for example, this is the parent chain now. You can take anyone as the parent chain. So this is the parent chain. Obviously, this will be the substituent. Tell me, is this point clear? Tell me quickly, is this point clear? Is this point clear? This functional group does not have any carbon. That's why we include carbons. We include carbons. Is this point clear? Obviously, after nomenclature, once nomenclature will be completed, after that it will be isomerism. Then it will be electronic displacement effects known as GOC. After that it will be hydrocarbon. After that it will be 12th portion. Okay. Now, is this point clear? Is this point clear? Now, have a look. Is there any principal functional group? Principal functional group is present, yes or no? Principal functional group is present, yes or no? It's present. It is present. And which one is principal functional group? This is the principal functional group. Now look towards principal functional group. This is having carbon. So this is carbon containing principal functional group. So if principal functional group is carbon containing, obviously that carbon should include in the parent chain. That should include in the parent chain. Now look towards this. If it should include in the parent chain, so it can be like this. It can be like this, in this fashion. In this fashion, principal functional group is included. Yes or no? It's included. In this fashion, it's also included. Have a look. Have a look. But my dear lovely students, principal functional group is included in this chain as well as in this chain. But after principal functional group, our preference goes to multiple bond. That means our parent chain must contain principal functional group and maximum number of multiple bonds. Now tell me, is there any multiple bond? Is there any carbon-carbon double bond? No. Is there any carbon-carbon double bond? Yes. So this is our parent chain. This is our parent chain. This is our parent chain. Now, 1, 2, 3, 4, 5, 6 carbons are there. 1, 2, 3, 4, 5, 6, 7 carbons were there. Sir, this was having more or maximum number of carbon atoms. Why this is not the parent chain? Because first of all, give preference to principal functional group. After that, give preference to multiple bond, as multiple bond is also present. So that means our principal functional group as well as multiple bond must contain, must be present within the parent chain. These must be present within the parent chain. And if these must be present within the parent chain, then this will be the parent chain, obviously. So this will be the side chain. This will be the side chain. Is this point clear? Is this point clear? Here, it's very simple. This will be the parent chain. It's very simple. And this will be the side chain. Now tell me, is everything beta clear to you? Is everything clear to you? Is everything clear to you? Now, I will be sharing the PDF of today's, session in my Telegram channel, which is t.me/KK Sir Chemistry class. But this is a new Telegram channel, my dear lovely students. So you have to search this in what we call Google. You have to search this in Google, but remember, no letter should be capital except this K and this K. And there should be no gap in between these. So t.me/KK Sir Chemistry class, there should be no gap, and capital K, capital K. These two Ks should be capital. Rest, everything is small. Rest, everything is small, beta. So this was all about today's session, my dear lovely students. So I thank you all for your patience, and God bless you all, beta. God bless you all, beta. So this was all about today's session. This is all about today's session. So take care, bye-bye, and God bless you all.